Okay, so in section 8.4, you're going to be looking to test the difference between proportions rather than the difference between means. So remember that proportions, this is just going to be looking at claims about a certain percentage from the population. We did tests for one proportion back in chapter 7, so this will just be tests that are comparing two proportions. So like I always do, I've defined your conditions, things you need to check to make sure that you're going to be able to use the normal distribution. And then I've gone through and given you the notation that you're going to be seeing here as well. Mainly you've got your population proportions that you're going to be comparing in your claim. You've got your sample proportions that you'll be calculating based on your data. Remember, a sample proportion just takes the number of people in a particular group and divides by the total to get that percentage. You are going to have a couple of new values to calculate here that we have not seen before. It's a p-bar value. It's just kind of a weighted value for an overall proportion, assuming that the proportions are equal to each other. You've got your basic steps for the hypothesis test, pretty much the same steps that you see with every test. Like I said, you're going to be comparing the proportions. You're going to use the standard normal distribution, so critical values are going to be values of z here. And then, of course, you've got your standardized test statistic formula that you'll be evaluating here to make your decision. All right, so we're going to walk through the first example, and then we'll talk about the other examples when I see you guys next class. But again, I want you to make sure that you go ahead and start at least practicing the information in section 8.4 before class on Tuesday, because we are going to be testing on chapter 8 on Thursday. All right, so like I always do, first thing, I'm going to read through, write down all my information, and make sure that I identify my claim, that I know what I'm testing. So notice we're given information about a survey. For each survey, you're given a total number of people, and you're given a number of people who wear a helmet. So if I write down all this information first, my first survey, so this will be my first group, has a sample size of 300, and the number of people who wear a helmet is 183. In my second survey, I've got the same sample size of 300, but the number of people who wear a helmet here is 201. Now notice what I'm asked to test here, my claim that I'm given, is in terms of a proportion. Specifically, I want to test the claim that the proportion who wear a helmet for the first group, the Northeast, is less than the proportion who wear a helmet in the second group, which is the Midwest. So my claim that I'm testing here would be that P1, the proportion for the Northeast, is less than P2, the proportion for the Midwest. Now, as soon as I see that I'm testing here comparing proportions, I'm going to go ahead and calculate all the different values that I'm going to need to run this test. So I've got my sample size, I've got my number of successes, we call them. So I'm going to go ahead and use that information to calculate the sample proportion for each group. So the sample proportion for group 1 is going to take the 183 who wear a helmet, divide by the 300 total, and that's going to give me a sample proportion of 0.61, or about 61% of the first group. I'll do the same thing for my second group. My sample proportion there will take the 201 people who wear a helmet, divide by its total of 300, and give me a sample proportion of 0.67, so about 67% in the second group. Now, to run this test, we are going to need to calculate a new value, and this is going to be that weighted value for the proportion, P bar, and it is calculated by taking the number of successes in each group, adding those together, and then doing the same thing with their sample sizes as well. So x1 plus x2 divided by n1 plus n2. So when I evaluate here, I'm going to get a weighted value of 0.64, about 64%, and I'm going to use that to calculate Q bar. Remember, this just looks at the failures. So if P looks at the ones who do wear a helmet, then Q looks at the ones who do not. And it is always found by just taking P and subtracting from 1. All right, so now I've got everything that I need to run my test. I do want to do a quick check here to make sure that I am okay to use the normal distribution. And I can do that by just checking these values here based on the sample size and the values of P bar and Q bar. Just a quick check to make sure that each one of those products is 5 or more. We are good here, so we're going to be fine to use the normal distribution. If any of those things were not 5 or more, then I would not be able to run this test. Okay, so now we're ready to set up our test. Remember, we had a claim that P1 was less than P2. Proportion for the first group, less than the proportion for the second group. So just like I always do to set up my test, I'm going to look at the claim, and I'm going to look at its opposite. Opposite of less than would be greater than or equal to. And that will allow me to define my null hypothesis will be the one with equality. My alternative will be the one with inequality, and that is my claim. So I'm going to be looking to see if I can support that claim since it is in the alternative hypothesis. Now, my next step is going to be to get my rejection region, my critical value. I'm using the standard normal distribution here. I look back at the initial setup. I see that HA contains less than, and that lets me know this is a left-tailed test. So I'm going to shade my rejection region in the left tail of the curve, and then I'm going to use my level of significance as the area of that shaded rejection region. Now, if the area of this region is 0.10, I'm going to use my standard normal table to find the corresponding value of Z. So looking for an area of 0.10, the closest I can get is right here at 0.1003, and that's going to tell me the critical value is negative 1.28. So my rejection region will be any values less than negative 1.28. All right, now at this point, I'm going to calculate my standardized test statistic that I'll use to make my decision. Now, just to let you know what I'm evaluating, I'm going to be plugging into this formula right here. I've already calculated everything that I need, and we are going to be testing against a difference of 0. So basically in the numerator, all I'm going to have is the difference between the sample proportions. All right, so here's all my information. My sample proportions are 0.61 and 0.67. I'm going to take the difference between those two. I'm going to divide this by the standard deviation, which for comparing proportions, I'm going to use the weighted values of P and Q. So I'm going to take my 0.64, multiply by 0.36, and then multiply that by 1 over the sample size for each group. Now, when you plug this into your calculator, the main thing to remember, you're going to need parentheses around everything that's under the square root to make sure it stays underneath that square root, and you will most definitely need parentheses here around that sum. So be careful with your evaluation there. Make sure that you're plugging into your calculator correctly, but you should get a z-value of negative 1.53. And then just like I always do, I'm going to take that, I'm going to compare it to my rejection region. Negative 1.53 is less than negative 1.28. What's important to us, it's inside the shaded rejection region. And that will tell us that we should reject the null hypothesis. Rejecting the null hypothesis means there is enough evidence. The test was conclusive. It was able to do what it was set up to do. And because our claim is in the alternative, we will be supporting the claim that the proportion who wear helmets is less in the first group, which was the Northeast, than it is in the Midwest.